Okay, guys, so I know I did kind of a crappy job of explaining conjunctions and disjunctions. So make sure you look at the explanation on Alex. It's pretty simple as far as analyzing language goes. And that's kind of what this lesson is all about too, these reasoning. This is actually just an explanation of symbolic translation of negations, conjunctions, and disjunctions. Okay, so this, you just, again, if you go look at the notes, you're going to be fine with them. At least it helps, I think. Did I did it? Hang on. Did I copy? I didn't. I'm sorry. I'm going to go back. I literally just did this and forgot if I did. I thought I picked the notes. I did. I don't think I included them on the slideshow. Oh well. So there are some good notes in the explanation, very simple notes, okay? So make sure you do copy them down if you need to. So here's the idea. When you're given statements, okay, they're given symbolically, they're given a letter like P and Q. Okay, so the car is red. Okay, that's a statement. The cup is blue. Okay, Sally is nice. Those are all statements, right? And they're given P and Q. Okay, the way we write them is P. Okay, if there's an arrow, Q, that means if P, then Q. Okay, if it goes like this, that is a conjunction, and that would be containing the word and. Okay, if P and Q. Okay, this is a disjunction. Okay, and that would be or. That would contain the word or. Basically, because there's a choice. Disjunction means there's a choice. Like you don't have to do both. And means you do both. If P, then Q. You can also have this here, which we will talk about. It's called biconditional. Now, how important are these things? Honestly, this is just an exercise in logic for you. We probably won't even touch on this much after this little particular pie slice, but it's good to be exposed to it because it's good for logic. It's good for understanding symbolically how to represent stuff. And you will hit we will be doing a lot of this and a lot of this later. Okay. Biconditional means if and only if. That's the expression. What it means is that it's true both ways. Okay. So if you read it one way, you go, oh yeah, that's true. And then if you read it the other way, you're like, oh yeah, that's true. Okay. So that's biconditional. Okay. These are the representations. Then you have this symbol. That means not. Okay. That little symbol means not. So here we got P says the car is red. Q, the car is a convertible. Okay. A says the car is not a convertible. So look, that relates to the statement Q, the car is a convertible, but it says it's not. So it's the negation. So how do you represent it? It's not Q. Okay. The car is a convertible and the car is red. Okay. So the car is convertible is Q. So we put that first. And then you're going to put a conjunction because it's and the car is red. Q. Okay. Now it says P disjunction Q. That means or, and it means P comes first. So that would be the car is red because that's P, or the car is a convertible. Did I spell that right? No, I didn't. I put tibble. Okay, there you go, convertible. Because that's Q. See, this part is Q and this part is P. Get the idea, you guys? It's really just matching. To me, it feels like matchy. Just match the pieces. Okay, this is one for you guys. Okay. So wow, I actually did some. Okay, so you try this one. You can pause the tape. All right, so hopefully you paused it and you tried it. If not, here we go. P is, it is fall. Q, we are going walking. Okay? We are not going walking. That is not Q. That's the symbol for not. And walking was the Q. It is fall and we are going walking. I wonder if they're all like this, where they're all just the same thing. P and Q. Okay? It's and this is the P and this is the Q. It says P or Q. So it is fall or we are walking. Okay, next. Oops. Let's take a look at this one. It says symbolic translation of conditional and biconditional statements. Basic. All right, so conditional is if then. Biconditional is if and only if. Okay, so consider the statements P and Q. We are having sushi for dinner. It is Sunday. Okay, so your job here is to just figure out how to represent it. Again, it is Sunday. Do you see this? If and only if. Okay, we are not having sushi for dinner. This is the Q piece. See, it is Sunday. We are not having sushi. Oh, see the word not? That one's positive. So this is not P. So you represent it as Q, start with Q, if and only if is an arrow going forward and backward. That's how you represent if and only if is this way. If then is this way. Okay, and then not P. Then look here. It says P, then not Q. So first you list P, which is we are having sushi for dinner. We are having sushi for dinner. If we are having sushi for dinner, I suppose that should be then, because it's an if then it is not Sunday. See the not symbol right here? And Q is Sunday. Okay, you try now. I'm going to go ahead and give you one to do, I think. Hang on. Let me erase that. Come on. See if I can get it to go. Here it goes. Okay, so you guys try this one. Pause it. All right, so check your answers. Consider statements PQ. So Kevin is hiking. Rita is in geometry class. Really, they should have nothing to do with one another, but whatever. Okay, Rita is not in geometry class. So that is not Q. If and only if, arrows both direction, Kevin is hiking. That is P. Okay, this one says not Q. So that would be Rita is not in geometry class. And we need to put an if there because it's an if then. So if Rita is not in geometry class, then Kevin is hiking. And you can see that these really don't have anything to do with each other, but they're getting you used to just using symbols. Okay. Man, I keep doing this. Let's get this down. Okay, the next one. A conditional statement has the form if P then Q. You write it like this. In such a statement, P is the hypothesis, Q is the conclusion. Okay. So the converse. Now, okay, these are, I didn't get the title of this one. Sorry about that. Okay, these are actually the notes for this section. And I did this because this is what I would be writing down. Okay, hello, give me a highlighter. Here we go. Okay, this is important. Okay, so here we go. You start with the conditional statement. Let me just do this in black, okay? You have a condition. Let's try not doing highlighter. Oh my God. Conditional statement. Okay, the conditional statement is if P, then Q. Okay, and it looks like this, P, then Q. Okay, that's the symbolic representation. All right, then you have something called the converse. If you think of converse, it means kind of the opposite-ish. So it is this right here. If Q, then P, or Q, then P. Okay, what that means is you just flip it. You flip the hypothesis and the conclusion. Okay, then they have something called the inverse. The inverse, take a look right here, okay? And you just need to copy this chunk down because it's something you have to learn. And you actually don't even have to learn it. You guys can write it down in your notes and have it for your exercises, okay? The inverse, okay, the inverse of if P then Q is the statement, if not P then not Q. So the inverse is basically making everything a not, okay? So the inverse is, and this is not very nice and neat. It should be like this, you guys. Okay, so inverse means if not P, then not Q. And then the last one is a contrapositive, and that is the other way. So you need to have these on hand because you're going to need to be able to form those sentences. Not Q, then not P. This might be an exit ticket today. Okay, I'll just give you a conditional statement and then ask you to name one of these. Okay, so take note of what they are and then answer the next questions. Let me see, or answer the questions that are there. So you're just flipping it around. I don't know if I actually gave an example. I don't think I did because I felt like it is something that you can do by just picking the P and the Q and then switching them around. So this is the last item on the notes today, and this is about evaluating the truth of a biconditional and conditional statement. Okay, so remember, biconditional, again, is if and only if. So if and only if. And conditional is, okay, if, then. All right, so here it is. The table below gives the material of each item in Kayla's jewelry box, okay? These are the only items in Kayla's jewelry box, so don't think there's more in there. Okay, this is it, all right? So she's got a pendant made of copper, bracelet silver, necklace copper, hairpin out of gold, and a ring out of platinum. Okay, so it says complete the parts A through C. Okay, so now what I did was I copied this piece right here. Okay, that was here. And I just copied the end of the, I didn't have enough space to copy the whole thing. It doesn't let me snip it. All right, it says write the following biconditional statement as a conditional statement and its converse. Okay, so converse, again, if you need to remember what converse is, go back to your notes. Okay, converse, it just means to flip it. Okay, Q, if Q, then P. Okay, so if and only if, so this is going to be an if and only if that they're giving us. An item is made from copper if and only if the item is a necklace. Okay, so first you're going to write it as a conditional statement. So instead of if and only if, you're going to write if an item is made from copper, I'm going to call this P. I'm going to call this Q because I'm not going to write all this stuff down. So you would write if P, then Q. If an item is made from copper, then the item is a necklace. Okay, the converse is, remember what the converse is, it means switch the Q and the P. So you're going to say if the item is a necklace, then the item is made from copper. Okay, all you're doing is switching them. Use the table to determine the truth value. So now you're trying to figure out if it's true. So is the conditional statement true, which is if it is made from copper, then it is a necklace? Well, look, You have two things made out of copper and you have a pendant. So that would be false because there is a pendant that's also made out of copper. The converse, let's try the converse. If Q, then P. If an item is a necklace, then the item is made from copper. Well, look, we only have one necklace and it is made out of copper. So yes, that is true. Determine the truth value of the biconditional statement. An item is made from copper if and only if the item is a necklace. Well, both of these must be true. The conditional and the converse must be true. To evaluate an if and only if statement, you need to be able to say that this condition is true and that the converse is true. You can read it both forwards and backwards. And so this would be false. Okay, let's try the next one. Oh my gosh. Okay, take a look at this one. This is another example. So if you want to pause, go for it. Okay. If not, do. I don't know. I don't know, you guys. All right. So here we go. Same thing. It says, write the following biconditional statement as a conditional and its converse. So basically, you guys, all we're doing is learning how to read this backwards and forwards. Okay. If a light bulb was red, P, then the light bulb costs $5. So if P, then Q. This one's going to be if Q, then P. If the light bulb costs $5, then the light bulb was red. Okay, so that's how you fill in that part. Now we need to figure out the truth values, and this is what we're going to use to do that. Okay, so if the light bulb was red, then it costs $5. Let's see, if it's red, it costs $5. Yup, that's true. Okay, the converse. If the light bulb costs $5, then the light bulb was red. Well, look, indeed, it's the only one that cost $5, so that would be true as well. So guess what? The biconditional statement is true because both of these are true. I think this might be it. Yep, that's it.